Welcome to Think Global Education Services. In this video, we will learn about Maxwell-Boltzmann distribution curves. According to kinetic theory of molecules, which says that particles of gas move randomly in different directions at high velocities due to the collision between the particles and with the sides of the container. While determining the rate of the reaction, the distribution of energy among the particles is of most concern. The distribution of energy is described by means of Maxwell-Boltzmann distribution curve. So, the Maxwell-Boltzmann distribution curve is a plot of number of particles with kinetic energy E versus the kinetic energy. As we see in the first graph, it is a plot of the number of particles with kinetic energy E along y-axis and the kinetic energy of the particles along x-axis. In this graph, the area under the curve indicates the kinetic energy of the particles. We know that activation energy is the minimum value of kinetic energy which particles must possess before they're able to react. So, the white area which shows the proportion of the particles in the sample which do not possess the minimum activation energy for the reaction, whereas the small blue portion which indicates that particles have the kinetic energy to carry out the reactions. So, by means of Maxwell-Boltzmann distribution curve, one can understand the energy of the particle in a reaction medium. With the help of Maxwell-Boltzmann distribution curve, the two main factors which determines the rate of the reaction can also be understood. One is the effect of catalyst, and the second one is effect of temperature on the rate of the reaction. As we can see in the first graph, the effect of catalyst. The catalyst will reduce the activation energy, thereby enhancing more number of particles to gain the activation energy to form the products. In this graph of probability of the particles with the kinetic energy or the number of particles along y-axis and kinetic energy of the particle along x-axis indicates the blue line indicates the distribution of the kinetic energy of the particles at a fixed temperature, and the portion in green color indicates the energy of the particles which have the minimum activation energy to form the products. But when we add the catalyst to the reaction medium, the catalyst will lower the activation energy, thereby increasing more number of particles to gain the energy to produce the product in a reaction chamber. And the next factor is the temperature. As we all know, by means of collision theory, with increase in temperature, particle gains more kinetic energy, and the rate of reaction will be increased, which can be explained by means of the Maxwell-Boltzmann distribution curve. The blue curve indicates a reaction at lower temperature, and we can see only few particles have gained activation energy to form the products. And the curve is narrow in nature. As we increase the temperature, the curve will be broadened and more number of particles will gain energy to form the products, which supports the collision theory that with increase in temperature, particle gains energy and more number of particles will react to form the products. Thus, by means of Maxwell-Boltzmann distribution curve, one can easily understand the energy of the gaseous particles in a reaction chamber and how energy is distributed among the particles.